Hi everyone. I am here to discuss some more examples on recursion. So I am considering 6 examples here. The first one is print 1 to n using recursion. That means without using any loop statement. Then print n to 1. Then sum of natural numbers. Then count digits in a number. Sum of digits in a number. And then checking whether the given string is subsequence of other string or not. So these are the 6 examples I would like to consider to explain more on recursion. So let us take the first one. The first one is print 1 to n. Print numbers 1 to n using recursion. Print numbers 1 to n using recursion. So as I told you earlier, for using recursion, we must write a function. Here I am naming the function as print 1 to n. It takes one parameter, that is n. Then what is the first thing I will do soon after I try to write a recursive function is I will define the base condition or stopping condition or exit condition. So all these three refer to the same. So what is the base condition I am going to write here is if n becomes 0, return. This is an empty return and nothing will happen here, just it will bring the control out of recursion. Else I will call the same function print 1 to n. Now the problem reduces to n minus 1 and then I will print n. So I am, you see this step print 1 to n minus 1 will bring the control gradually to the base condition. So these are the two essential things one must take care while writing a recursive function. So what am I writing here? If n becomes 0, return, come out of recursion. Otherwise print 1 to n minus 1 and then print the last number. So most of the people get confused here. They will assume that this will print the numbers in reverse order. Why? Because print n statement is appearing first. No, it won't happen until all the, as I explained in one of my previous videos, until all the recursive calls are completely explode, the statements that are placed after the recursive calls will not be executed. So this will print 1 to n. Let me write the driver code for this. In driver code, what I will do is I will read n int input n equal to, we have to give the value of n here. Then let us call this function print 1 to n of n. That's all. It will print the numbers from 1 to n. Let us execute this and see the output. Let us first give n as 10. It must print the values from 1 to 10. Yes, we got the output. The numbers are printed from 1 to 10. This is how we can write recursive function to print 1 to n. And sometimes during the technical interviews, they will ask us to print the numbers 1 to n without using loops. If they mention without using loops, you must understand that that is to be done by recursion. And this is one simple and good example for recursion. Next, let us take another task. Let us take another one. The second one is print n to 1 using recursion. That means we have to print the numbers in reverse order. For example, if I give n as 10, it must print the output like 10, 9, 8 and so on up to 1. Let me write a recursive function quickly. Let me name this recursive function as def print n to 1. It takes one parameter. Here also, if n is 0, I will write the base condition like this, return. Now, instead of pushing this print statement to the end of recursive call, what I will do is, I will print n first, print n, and then I will call print n to 1, n minus 1. Okay. Now, this will do the job. Let me write driver code. Next, read n from the user. Then let me call print n to 1, n to 1, n. Yes. If I give 10, it must print the output like 10, 9, 8, 7, 6, like that. Let me give 10 as input. Yes, it is printing exactly as we expected. So this is another recursive function we can use. So this question may be asked like print the numbers n to 1 without using loops. Then what we have to apply? We have to apply recursion. Next one. The third one is sum of natural numbers. Sum of natural numbers. For this also I will be writing a recursive function. Let me name the function as sum n and followed by n. Sum of natural numbers. We all know that we can use for loop or we can directly apply the formula n multiplied by n plus 1 by 2 to find the sum of natural numbers. Let us experiment the same with the recursive function. So for this also I will take the base condition as if n equal to 0, I will give return 0. Why? Because we have to return a value rather than printing. That's why I am returning 0 for base condition. Else return 1 plus sum of n minus 1, or I can write it like sum of n minus 1. Just like I wrote print 1 to n function, I will be writing sum n minus 1 plus n. Okay. So this will do the job. Let me write the driver code quickly. Read n value from the user. N equal to. If I give n value as 10, I must get the output 55. Print sum n 10. Got it? Now let me run this code. What is n value? 10. The first 10 natural numbers. Sum of first 10 natural numbers. If our code is correct, we must get 55. So what is the problem here? Yeah, print sum n. This is the case here. I forgot to give this sum n, and this 10 should be, we are writing a generic function, right? So sum n, let me call that with n. So these are the errors we have rectified. Then 10. So what is the answer we got? 55. Okay. So this is the recursive function to find sum of n natural numbers. Next, count digits in a number. The next task is count digits in a number. Count digits in a number. So for example, if I give the input as 1 2 3, the number of digits of that number will be 3. That is the output we must get. So let me write a recursive function for this. Let me call this function as digits, and the number is n. Then if n equal to 0, return 0, else return 1 plus digits of n floor division 10. That's all. So this is like we will continuously divide the number until it becomes 0. So while dividing the number, we are counting one, we are taking out one digit. That's why we are adding 1 to count. So finally 1 plus digits of n floor division 10 will give the total number of digits. Now let us write the driver code for this. Let me read n equal to int of input n equal to, then let me call this function print digits of n. That's all. Let me execute this code. Enter n is, let me give 1 2 3. If our code is correct, we must get 3 as the output. Correct. Let me run the code with another input. How many digits are there? 7 are there. We must get the answer 7. Yes, perfect. It is working. Now let me take another example. What is that example? Sum of digits in a number. The fifth task is sum of digits in a number. Uh, Sum of digits in a number. For example, if I give 1 2 3 as the number, the output we should get is 6. Okay, for that let me write a recursive function daf sum digits. Sum digits. I am naming the function as sum digits, then n. So for this also I will take the base condition as if n equal to 0, return 0. Return 0, else return some digits. Please carefully observe how I am writing. Some digits floor division of 10 plus I have to extract digit by digit. So for that reason I will be finding out the remainder. So how can we get the remainder? N modulo division 10. So every time we are separating one digit and it is getting added. This some digits of n floor division 10 will be the partial number which is separated after the last digit. So this process continues until n becomes 0. So let me write the driver code. The driver code is like read n from the user. Int input, enter the number n equal to something, then print some digits of n. That's all. Run. N equal to 1 2 3. The sum of digits is 6. Yes, our code is working perfect. Let me run the code with another input. 1 5 6. We must get 12 as the answer. Yes, we are getting. So this is the code for sum of digits, finding sum of digits using recursion. Next, the last task is checking whether the given string is a subsequence of another string. So let us write code for that. Finding the status of whether the given string is subsequence or not. So let me take that as sixth example. Is subsequence or not? We can write iterative solution as well as recursive solution for this one, and it is a very interesting string problem actually, and this is a lead code problem, and the problem number is 392. If you want to explore that, you can explore and submit the solution there. So what is this problem actually? Let me explain it a bit. So let us assume there is one string t which is like a b c d e f. This is one input given, and another input given is another string. Let us assume it is ACE. Then now the question is S a subsequence of T? What is meant by a subsequence? Subsequence can be a substring, but it can be it is like the sequence of letters in S must be maintained relatively in T also. For example, if A is preceding C, that same relatively A must precede C in the original string. For example, if C comes before E, similarly C must come before E in original string. Then we can say that S is subsequence of T. Let me give another example. T equal to QWERTY, 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 and let me give the string as S. S equal to some EWQ. Can I say S is a subsequence of QWERTY? S is a subsequence of T? No. In the first case, the output will be yes. Output is yes. In the second case, the output is no. I think you can understand what is the difference between these two. Output is no. Why it is no? Though the characters are there, but the order of those characters is not the same in both the strings. Okay, so that's why we can say that the second one is not subsequence of the first string. In the second example, S is not the subsequence of T. So this we have to write with the help of a recursive function. So let us read, we have to read T, S, then we have to call the function. First let me write the recursive function is sub. It takes three parameters T, S and I. Initially I will be 0. That means we will be starting this comparison process from 0th position onwards. If I equal to len of S, two cases are possible here. If I equal to len of S, when I equal to 0 and S is empty, then that is obviously a subsequence. An empty string is a subsequence of any string. So here we have to return true. Another possibility is when the whole string S is processed without any hiccups or without returning false in between, in that case also it must return true. There are two possibilities here. One is when S is empty and another case is when S is completely processed. In both the cases, it returns true. Else, I will be taking exception handling in Python. This is like I would be getting the index of first character of S in T. Why I take the index of that? From then onwards I will start proceeding. I need not worry about all the characters that come before S of 0. So for that reason I will be writing like T dot index of S of I. When I is 0, S of 0 means the first character of S. We will start with the first character of S and that position is stored in J. Why we are putting this in a try block is, if that character is not existing in T, this index function will throw an error. So to handle that one, we are putting that statement in try block. So if that error is there, then that means that first character itself is not there in T. So that's why return false. Okay. Otherwise, if this is not the case, then return the same problem repeats is sub with a new t value. What is this new t value? Up to j we have checked already, so we will be interested from j plus 1 onwards. This s remains the same. S is used just for the sake of comparison. Then I will be updated to I plus 1. So this is the code for checking whether the given string is a subsequence of another string or not, or whether S is subsequence of T or not. So this is an efficient code we can write with the help of recursion. Now let me write the driver code. The driver code is like T equal to input, enter T, then S equal to input, enter S. Now let us call this function if is sub of t comma s comma 0. The starting value of I is 0. If it is true, then print yes, else print no. Okay, so if everything is, if we have not committed any syntactical mistakes, so this code should work without any errors. Yes, it is coming. So let me give the string as a b c d e f. S as a c e. Yes, it is a subsequence. Let me run the code with another input. A W E R S. Okay, then let me give the string like R S W. Though the characters are there, it must not be a subsequence. Yes, it is working fine. And I hope you understood all these recursive functions examples. I have taken 6 examples here, and if you would like to look at the code, you can pause the video and you can have the code, and please try with pen and paper to understand it much better. Then you can experiment with this code with your own inputs and expected outputs, and I hope the video is helpful to you. So if you like it, please subscribe and please like the video. Thank you.